Hi to everyone, welcome to NCC channel. My name is Naresh, chemistry lecturer. Today I would like to discuss one of the topic from chemical bonding, that is dipole moment. Dipole moment. Here, polarity of a molecule indicated in terms of dipole moment. Polarity of a molecule indicated in terms of dipole moment. For example, if the dipole moment equal to 0, if the dipole moment equal to 0, and that is non-polar molecule. Non-polar molecule. If the dipole moment not equal to 0, that is polar molecule. Polar molecule. So what is meant by dipole moment? What is meant by dipole moment? Already you know that. For example, I am taking a molecule HCl, hydrogen chloride. The electronegativity of hydrogen is 2.1. The electronegativity of chlorine is 3. So in this, chlorine has more electronegativity. In these two atoms, chlorine has more electronegativity. That's why this chlorine attract the bonded electrons towards itself. Chlorine attract the bonded electrons towards itself. Every bond contains 2 electrons. Bond nothing but 2 electrons. So due to more electronegativity, this chlorine attract the bonded electrons towards itself. Now it gets partial negative charge. Partial negative charge. At the same time, it gets partial positive charge. Partial positive charge. Now dipole moment is the product of magnitude of a charge. Magnitude of a charge, either cation or anion charge, and the distance between two ions. The distance between two ions. The distance between two ions is called dipole moment. See, dipole moment is the product of magnitude of charge, either cation or anion, and the distance between two ions. Charge indicated with Q and the distance D. This is the dipole moment. Units of dipole moment, debye. Units of dipole moment, debye. Capital D, debye. Capital D. Now you see some examples. BeCl2. I am taking beryllium chloride. It is the linear shape. Now when you see the structure, BeCl2. Now dipole moment, does it has dipole moment or not? Now compared to beryllium, chlorine has more electronegativity. It has more electronegative nature. Now it can attract the bonded electrons towards itself. Now this chlorine attract the bonded electrons towards chlorine atom. At the same time, this chlorine attract the bonded electrons towards itself. For example, we assume chlorine is more electronegative nature. It is attracting the bonded electrons towards itself with some pores. At the same time, this chlorine atom attracting the bonded electrons towards itself with the same pores. So the resultant pores becomes 0. That means the net dipole moment is 0. That's why here dipole moment equal to 0, because it is a symmetrical shape, symmetrical structure. Now boron trifluoride. It is trigonal planar in the structure like this. Now compared to boron, fluorine has more electronegative. It can attract the bonded electrons towards itself. Now this fluorine attracting bonded electrons towards the fluorine atom. Now this fluorine is attracting the bonded electrons towards itself. Now the net force becomes 0, because it is a symmetrical shape. That's why the net dipole moment becomes 0. So here dipole moment equal to 0. Next, tetrachloride, carbon tetrachloride. It is tetrahedral shape, and the structure like this. It is also symmetrical shape. Compared to carbon, chlorine is more alternative nature. Chlorine is attracting the bonded electrons towards itself. This chlorine attracts the bonded electrons towards itself. This chlorine attracts the bonded electrons towards itself. This chlorine attracts the bonded electrons towards itself with some force. The net force becomes 0. That's why the net dipole moment is 0. Square planar. Next example, XeF4. XeF4 square planar shape. The structure is like this. Now compared to xenon, fluorine has more electronegativity. It can attract the bonded electrons towards itself. At the same time, this fluorine attracts the bonded electrons towards itself with some force. Both forces cancel with each other, and now this fluorine attracts the bonded electrons towards itself. This fluorine attracts the bonded electron towards itself with some force. This both forces cancel with each other. Now the net force, the net dipole moment is 0. Now octahedral SF6, SF6. The shape is octahedral. The structure is like this. And compared to sulfur, fluorine is more electronegativity. It can attract the bonded electron towards itself. It can attract the bonded electrons 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 towards itself. It can attract the bonded electron towards itself. Now the net force becomes 0 because it is a symmetrical shape. That's why the net dipole moment equal to 0. We see next example. H2O. The geometry is bend shape. The structure is like this. Dipole moment. Now compared to hydrogen, oxygen has more electronegativity. It can attract the bonded electrons towards itself. This bonded electrons also attracted by oxygen. Now the net was not equal to 0. That's why it has some dipole moment. That's why dipole moment it is not equal to 0. It has some dipole moment because it is unsymmetrical shape. NH3, it is pyramidal shape and the structure is like this. Now compared to hydrogen, nitrogen has more electronegativity, so it attracted the bonded electrons towards nitrogen. Now the net force is not equal to 0. It has some dipole moment because it is unsymmetrical shape, so the dipole moment not equal to 0. In ClF3 in T shape, the structure is like this. It contains 3 bond pairs and 2 lone pairs. Fluorine is more electronegativity compared to chlorine, so fluorine can attract the bonded electrons towards fluorine. Now the net force not equal to 0. That's why it has some dipole moment, so dipole moment is not equal to 0. In SF4, it is CSR structure. It is unsymmetrical shape. Fluorine has more electronegativity. It can attract the bonded electrons towards fluorine like this, and we say the net force not equal to 0. That's why the net dipole moment also not equal to 0. It has some dipole moment. Next BRF5, it is square pyramidal. It is unsymmetrical shape, and compared to bromine, fluorine has more electronegativity. It can attract the bonded electrons towards fluorine. Now it is unsymmetrical. It has the net force not equal to 0. That's why the net dipole moment also not equal to 0. Now last one, cis and trans. It is a cis molecule, it is a trans molecule. Now see cis molecule, it has chlorine has more electronegativity compared to carbon. It can attract the bonded electrons towards chlorine. Now carbon and chlorine is more electronegativity. It can attract the bonded electrons towards chlorine. Now see the net force not equal to 0. That's why it has dipole moment. So the dipole moment not equal to 0. Now you see it is a trans molecule. Chlorine has more electronegativity compared to carbon. This chlorine also more electronegativity compared to carbon atom. This chlorine can attract the bonded electrons towards the chlorine atom. This chlorine also attracts the bonded electron towards itself, towards the chlorine atom. Both are in opposite side, so these both forces cancel with each other. That's why net dipole moment is 0. If the dipole moment is 0, that is trans molecule. If the dipole moment not equal to 0, that is cis molecule. In this way we can explain dipole moment. I hope that all are understood this concept. Thanks to all for watching my video.